Hello, today we are going to be looking at complex and imaginary numbers. So complex and imaginary numbers are needed to find solutions of equations that cannot be solved using a set of real numbers. For example, if you have x squared equals negative 16 and you want to solve for x, typically what you would do is you would move everything over to one side so you have x left by itself, and then from x squared you would take the square root of both sides to give you x equals the square root of negative 16. Well, in this case, you would have to use a complex number or an imaginary number because there's no real number multiplied by itself that's going to give you a negative number. Even if you had negative 4 multiplied by a negative 4, that's going to give you 16. So again, there's nothing multiplied by itself that's going to give you a negative number, and therefore imaginary numbers were created. Before we go into some problems and examples, let's look at a couple of the properties of imaginary numbers. So an imaginary number is typically denoted with a lowercase I. And I is equal to the square root of negative 1, which is what we see here. If I is equal to the square root of negative 1, then I squared would be equal to negative 1. All we would need to do is square either side, and that is how we're left with negative 1. A complex number is typically denoted a plus bi, where a and b are real numbers. B in this case would be the coefficient of I. When adding imaginary numbers with real numbers, you can treat I similar to a variable x, in that like terms get added or subtracted together. And we will look at a couple of examples where we would have to do that. Now, if we go to this example that we have here at the top, and we utilize our rules of imaginary numbers, then we can easily solve for this value. In this case, the square root of negative 16 is equal to the square root of negative 1 multiplied by the square root of 16. Using our imaginary number rules, we see that the square root of negative 1 is equal to I, so we can move an I out in front, and we know that the square root of 16 is 4. Therefore, we know that this answer is equal to plus or minus 4i. And this is our answer. And in this case, if we were to multiply these together to see if we can get negative 16, if we take 4i squared, that's the same thing as doing 4 squared I squared. 4 squared is 16. I squared from our rule of imaginary numbers is equal to a negative 1. Multiply these together and we still get negative 16. Similarly, if we have a negative 4i, then what we do is take the square of that. Negative 4 squared is equal to 16. I squared is equal to a negative 1, and therefore 16 times negative 1 is negative 16. And these are both exactly what we wanted to get for the value under the radical. Let's practice with a couple of problems. Okay, let's look at two different examples. We have 3 plus 4i plus the quantity 2 plus 5i. Well, this can be rewritten as 3 plus 4i plus 2 plus 5i. If we were to treat I like we were working with a variable x, all we would need to do is combine like terms. We see that the 3 and the 2 are like terms, and we also see that the 4i and the 5i are like terms. And so you would just need to combine those terms. 3 plus 2 is 5, and then you get 4i plus 5i, which gives you 9i, and this would be your answer. And this is a complex number because, again, we have 5 and 9 both being real numbers and I being an imaginary number, which then makes this answer a complex number. And again, we know that complex numbers are typically written in the form a plus bi. Looking at our next example, again, we're going to do the exact same thing as far as treating I like a variable x. And so in this case, we have 3 times 2, which is 6, 3 times 5i, which gives us 15i, 4i times 2, which gives us 8i, and then 4i multiplied by 5i, which gives us 20i squared. Okay, combine like terms. We see we have an I here, and then we have an I squared, and then we have our constant here. So what we would need to do first is simplify. From our rule, we know that I squared is equal to -1. Therefore, this can be rewritten as 6 plus 15i plus 8i minus 20, because this is really 20 multiplied by -1. We can further simplify this now by combining this like term and this like term, and then combining this like term and this like term. If we were to combine all of the like terms, we would get a -14 plus 23i. This problem cannot be simplified further, and therefore this is our answer, and it is considered a complex number. Okay, let's look at an example where we are actually working with square roots. We are able to utilize both of the rules that we saw for imaginary numbers. In this case, we would simplify this problem. We would get 6 minus 2 square roots of -16 minus 3 square roots of -4 plus the square root of 64. From here, we're going to simplify. We get 6 minus 2 square roots of -1 multiplied by 16 minus 3 multiplied by the square root of -1 multiplied by 4 plus 8, because 8 times 8 is 64. The square root of 64 is 8. And as you notice here, I like to separate out the -1 from the 16, so I know exactly what I need to do, and we're not skipping any steps. From here, we get 6 minus 2, the square root of -1 from our rule is I, square root of 16 is 4, minus 3, square root of -1, I, square root of 4, 2, plus 8. Now we need to further simplify this down, both of these. So we get 6 minus 2 times 4 is 8i, minus 2 times 3 is 6i, plus 8. All we need to do is combine like terms. So we have this term and this term. Similarly, we have this term and this term. After we combine terms, we get 6 plus 8, which is 14, minus 8 minus 6, which is -14i. And this is our final answer. You'll often see imaginary numbers when solving the quadratic equation. And if you need a refresher on the quadratic equation, I will link a video in the description below. And because imaginary numbers are so prominent when solving the quadratic equation, let's let our last problem be an example of that. Okay, looking at our final problem, we're going to use the quadratic formula to solve this. And in this case, we're going to see an imaginary number appear. And this typically is when you will use imaginary numbers. So with this, we have the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which then can be simplified down to a -1 plus or minus the square root of 1 minus 4 times 4 is 16, 48 all over 8. This can be simplified down to -1 plus or minus the square root of -47. This is going to simplify down to -1 plus or minus the square root of -47, all divided by 8. With that, we can rewrite this as -1 plus or minus the square root of -1 multiplied by the square root of 47, all divided by 8. We know that from our imaginary numbers that the square root of negative 1 is I, and therefore this can be rewritten as negative 1 plus or minus I times the square root of 47 divided by 8. Your first answer is going to be negative 1 over 8 plus I square roots of 47 divided by 8, and you're going to get negative 1 over 8 minus I square roots of 47 divided by 8. And these will be your two answers, which are going to be equal to x. And this will solve this problem at 0. And there you go. Just remember, as you're working through and simplifying the problems, treat I as you would treat a variable until you're ready to simplify the imaginary number. From there, separate out what you know to be true from the rules that we've discussed, and you should get it right every time. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.